goal this evening as part of SDV Social 2024 is to examine software-defined vehicles to a further degree and what this transformation means for all of us in this room. I'm joined this evening by three distinguished panelists: Colt Correa, Chief Operating Officer of Intrepid Control Systems; Paul Fleck, the founder and CEO of Dataspeed; and Marty Gubow, Product Manager at Keysight Technologies. Colt has nearly 25 years of experience working on software and electronics hardware with numerous types of vehicle networks, and is the author of a leading book in this field, which you saw on the table out there, now in its second edition, titled Automotive Ethernet, The Definitive Guide. He's also authored numerous IEEE and SAE publications and has been awarded 6 U.S. patents. Colt, welcome. Thank you for being here.
Thank you.
By the way, Paul started Dataspeed in 2009, initially to provide engineering services in a variety of areas, but then he later narrowed that focus to automotive robotics and specifically autonomous vehicles. One of Paul's most notable achievements has been the development of Dataspeed's drive-by-wire kit, in addition to customized autonomy software, full system integration, and cloud connectivity. To date, over 500 vehicles in the autonomous vehicle industry feature Dataspeed's drive-by-wire kit. Paul, welcome. Thank you.
Thank you.
Marty holds a Bachelor's of Science degree in Electrical Engineering from Lawrence Tech and a Master's of Science in Engineering Science from Rensselaer Polytechnic Institute in New York. He is currently the TSN Program Manager for the Network Test segment and is responsible for the strategy of Keysight's TSN products. Marty, welcome. Thank you for being here.
Thank you.
For this panel, we're going to be doing an around-the-world style. So each panelist is going to have the opportunity to answer each of the questions and share their insight and their expertise. We will have, at the end, a brief Q&A session, so please hold your questions until that time. If we don't get to your questions, please speak with our panelists afterwards or connect with them on LinkedIn. Colt, you are up first. So our first question here is, how do we define this term that we see everywhere in the industry, software-defined vehicles? What key elements differentiate a software-defined vehicle from a traditional vehicle?
So I think you had a good introduction there to define software-defined vehicle. But for me, first of all, software-defined vehicle means a lot of different things to different people. It's a marketing term. So depending upon where you're coming from, it means different things. But in general, for me, as part of the electronics industry, it's just the next progression of what's been happening for the last 30 years. You know, we see traditionally vehicles being a mechanical piece of machinery, and then, a little bit of electronics to do some fuel, control, spark control, and then now we've developed into hundreds of ECUs inside of vehicles, and the software inside of the vehicle becomes more of a distinguishing factor as far as DNA goes. That's been happening for the last 30 years as a progression, and SDV is the next step beyond that, just the next progression, where essentially it's become more of a marketing term than anything else, because companies want to have so much software involved in the vehicle that they can even allow after-sale revenue from the vehicle. So it's like we hear the term, mobile, mobile phones, that are on 4 wheels. So that's really kind of the push for features that can, the next sort of ability to generate more revenue for automobile companies is to generate revenue after the sale. So we see that already with Tesla, with Super Cruise, where there's subscription models, and so the more automotive companies can be successful in generating revenue after the sale of the vehicle, the more profitable that they'll be, and that's the big push towards SDV technologies.
Colt, thank you. Paul, same question to you. How do we define the term software-defined vehicles? What makes them different from traditional vehicles?
Well, I think, if you go back to automotive electronics, way back when, before they had processors, you started out, you had electronics in cars, and the introduction of the microprocessor. So, the automotive companies had to start hiring, coders, right? They called them coders back then, or now they're software engineers. But, back then, the product was like the ECU, and then software was just kind of a part of the product that went inside that ECU but it was the hardware. The software was the enabler to sell the piece of hardware. They wanted to sell that piece of hardware. Well, nowadays, I think what you're transitioning to is the hardware becomes ubiquitous, right? With zone controllers and things like that. And the differentiator to the end user, the customer, is the experience that they'll get through the piece of software, so you have, multiple different companies that are trying to create a user experience through software where, the embodiment is in hardware, but really it's the differentiator is in the software, so.
Marty, same question to you, my friend. How do we define the term software-defined vehicles? What makes them different than traditional vehicles?
Yes, when I first heard this term, software-defined vehicles, I thought back to the early days of microcontrollers in cars. And I thought back, even in the very early days, we had calibration values, and we could change the options in some of the experience by the user by just reprogramming. Back then it was EEPROMs, then moved to Flash. So software's always been a very big part of the configuration of what's in the vehicle. But I think what we really mean by the term software-defined vehicles today is what is the software is defining the product differentiation that you have in your vehicle. So if vehicle companies saw no differentiation in engines or transmissions or battery packs or motors, they would just buy them on the outside. But when a vehicle company tries to make itself different, it has to find what are the things that make my vehicle different from somebody else's, and what's going to make them buy my vehicle. And I think there's a awareness now that the software experience in the vehicle is really the defining factor of what people buy. People are going to go to the showroom because they have a certain operating system or they have a certain CarPlay and so forth. So I think and the auto companies are really realizing that this is a huge differentiator, and they have to treat software like it's an engine, a transmission, a core element of the vehicle, and you see that today because you see companies moving away from standards like CarPlay and Android Auto because they want to differentiate themselves and make themselves truly different. So to me, that's really what people feel like software-defined vehicles are.
That's excellent. Thank you, Marty. Now that we have this framework laid, this foundation laid, what are the adaptations that must be made to the electronics and the electronic architectures of a vehicle to effectively transition to a software-defined model? Colt, we're back to you.
Yeah, so what we're seeing is, again, I think it's sort of like a progression where we've had a lot of electronic content being added to the vehicle over the last 30 years. And the architecture inside for electronics engineers is called domain-based architecture. That means you have a specific set of hardware and software dedicated to like powertrain engines or propulsion system or brakes. And the new paradigm as we're moving forward, the real software-defined vehicle is to combine all the intelligence from, let's say, 100 different ECUs in the vehicle into, as much as possible, into a single piece of computing power, which is like a super brain. And that gives you the ability to control all the software, the OEM, the ability to control all the software, download into a single ECU, and then the mechanical parts that actually control the vehicle, the actuators and sensors, then become sort of dumb remote controlled devices. And so the architecture change that we're seeing is from what we call traditional domain-based architecture, where you have a network that's designed for ECUs and software designed for a particular purpose, a particular domain, like powertrain, brakes, HVAC, lighting, cooling, these kind of things, to a central processing unit that performs multi-functions, and then you remotely control the actuators and sensors over the network. So we see the network becoming more important, and just the centralization of electronic controller units, of many different units into as much as possible a single one inside the vehicle.
Thank you, Colt. Paul, we'll jump over to you. Just a refresher on the question, what adaptations must be made to the electronics and the electronic architectures of a vehicle to effectively transition to a software-defined model?
So, obviously, as you consolidate functions into maybe less ECUs but with more capability, the processing power has to dramatically increase, as well as the amount of non-volatile memory. You need that just to contain the large program sets. Your networking, you got to go to higher speed networks because of the amount of data that you're going to be moving around in real time. You also have to really pay attention to, some form of cybersecurity layer to ensure that, people with nefarious intent don't, inject something into the ECUs, especially doing it through the delivery of, a lot of these software features is going to be through over-the-air updates. So, that network controller, wireless controller that brings that data in, you really have to protect that coming in, so that you don't get code in there that shouldn't be operating in your vehicle.
Yeah, the one thing that I think of is in the original days of the ECU and memory, we would have an operating system running on the controller, and we call that bare metal. It would be one operating system. It could even be a custom, very simple operating system, talking right to the sensors, right to the hardware. Today, when we want software-defined vehicles, we want the ability to be able to add functionality, so we have to have a much more advanced architecture. So what we do is we tend to take different functions and put them in software elements like containers or virtual machines, so that we can isolate one function or a new software program that I download or a new functionality I have. You can't have all of these different programs trying to talk to the hardware all the time. So you have to have some driver level, you have to have containers that allow one program to be isolated from another program so that it can't corrupt its memory space for security. And as you add this complexity with containers and virtual machines, that drives a lot more processing power because there's a lot more overhead in those layers. And it also drives a lot more communication among systems. So software architecture has to change if we want to allow dynamic virtual programs to be installed at the whim of the customer, because we want it to be customized. We want it to be the mobile phone on wheels and be able to load my apps and so forth. So a lot of software behind making that all happen.
Marty, that's excellent. Thank you. Colt, we'll come back to you for this next question. So everything we've been talking about here, let's just take it one step further. How will these adaptations and changes impact the automotive electronics industry and ECU manufacturers in Michigan and even globally?
Yeah, so first, I think there is no such thing as a Michigan automotive industry anymore. It's very global. Everything is connected. Almost every manufacturer, and even including Intrepid Control Systems as a tools company, we're global. It's all connected together. So I don't think there is any such thing as localized industry anymore, number one. And then secondly, there's going to be a lot of consolidation. Like I said, we're moving from a situation where vehicles have hundreds of different ECUs from dozens of different suppliers to, as much as possible, a single central brain. So that's going to cause a huge disruption. That's number one. As far as number of suppliers, there's going to be some huge winners in supply base. There's going to be some huge losers. And secondly, the OEMs are bringing, as you said, software-defined vehicle. What does that mean? The OEMs want to control the software now, whereas in the past, you've seen software being created and distributed, created by large suppliers like the Bosches, Continental, Denso, and so forth, and they supply that to the manufacturers. And now more and more of the manufacturers want to do that themselves and only take the hardware from the supply base so that they can differentiate themselves from other manufacturers. So those are the big changes that are happening right now.
Paul, same question, just to refresh our memory and going with the theme that Colt said, the global automotive industry. How will these adaptations impact the automotive electronics industry and ECU manufacturers?
Yeah, so, again, if you go back into the history, the introduction of, or the use of electronics in the automobiles. So it used to be, a tier one supplier would have a feature or, something they're trying to sell to the OEM. Maybe it was a motor that did something. Well, the OEM would have that component supplier source out their own small, ECU that maybe controlled that function. Hence, that's why you'd have, 50 plus, separate little ECUs inside the automobile. And then they'd be talking either maybe a CAN network or some other network, or not talking on a network at all as a standalone ECU, right? So now, as you get this consolidation, right, and you have less ECUs, but the complexity of the remaining ECUs is going to go way up. And with that complexity, you have to have effectively contract manufacturers that have the equipment that can process, a CPU that maybe in the past might have been an 80-pin device to something that's got 1,000 balls on a VGA. And your small mom and pop little contract manufacturers, that there's quite a few of them in Michigan supporting the industry. Most of them probably won't survive. It'll go to the large ones. I guess Jabil comes to mind. The really large contract manufacturers. So you'll see continued, I think, consolidation of the manufacturing base for that.
Marty, same question here. Just to refresh our memory, how will these adaptations, everything we've been talking about, how does that impact the automotive electronics industry and ECU manufacturers globally?
So I was at a large OEM, and back in the very early days when we wanted to buy an ECU, we bought the ECU and the software from the same company. It was an integrated package. And it made it difficult to commoditize that ECU because everything was tied together. So as things evolved, the auto companies built their own I/O level layers so they could try to have different suppliers supply different hardware, and then they wrote the upper level software. But that was still tied to specific architectures. It still was based on the same microprocessor technology. You could only have so much flexibility. But now that we have virtual machines that are pretty common, what you tend to do is you virtualize the hardware, and that can run on a variety of different platforms. So I think you're going to start seeing software that's designed to run on multiple vehicles, just like we can take our favorite mapping program and run it on multiple handheld devices. We can run it on our car. You're going to start seeing industries where it's specialized in different components that get incorporated into the car, and a lot of competition between these modules, these software modules that get moved around. So I think it's going to really open things up, and it's going to be an interesting ride to see how, when you get into your car, how you can select. Maybe there's a driving mode from company A or a driving mode from company B that you like better.
Yeah. Marty, thank you, friend. Colt, we'll come back to you for this one. So everything that we have been discussing so far, what are the primary hurdles and considerations, and how can these challenges be addressed and overcome?
Well, one of the things that I like to say, it's kind of a joke, but if you look at a traditional network architecture of a vehicle, a domain architecture, you got powertrain, you got HVAC, you got lighting, on and on and on. If you look at the electrical schematic architecture at a high level, it's a very good representation of the internal structure of the people organization within an OEM. And often the different groups don't even talk to each other for their entire career. You know, so I see one of the challenges in this is how do we get multiple domains, HVAC, lighting, so forth, infotainment, to communicate in such a way that the software from those different groups within an OEM can coexist inside of an ECU, and you know, everyone gets the resources that they want, the priority that they want, and so forth. So I see that as a big challenge. And secondly, the supply base, like I think Marty said, is you've had specialized ECUs from manufacturers that do one function, and now they're going to have to, if they're going to survive, they're going to have to learn how to coexist with other suppliers that are competitive in the space within one ECU. So that's those are, I see some of the challenges, the biggest challenges of being not so much technological challenges, but organizational challenges.
Paul, same question here for you. Primary hurdles and considerations. How do we address and overcome these challenges?
So, you know, as these systems become more complicated, right? Obviously the engineers have to continually educate themselves and stay current with the technology, right? If you want to have a job long term. So that's one thing. The other thing too is obviously stay abreast of latest tool developments, like what Intrepid has ongoing, right? They seem to invest a lot in their tool set to stay current, because a lot of with software-defined vehicles and these zonal controllers, and you're gonna have quite a few different networks operating. So knowing how, understanding networks is a very important thing.
Yeah, I think the local school base, university base around, especially around Michigan here, is extremely important, because there's a lot more software engineers now than there are hardware engineers. It used to be we design a lot of stuff in hardware because it's the only way to get it done. Now we tend to just digitize it, and we'll use the DSP and we'll do it all in software because it's easier and we can get it done quicker. So we're taking advantage of the advances in technology and processing speed, but we need a lot more software engineers. And you see when you go to university today, the #1 major now is software engineering, computer science, and that's good. But there's a lot more to learn now than there was when I went to school. Software is a lot more complex. And it's just amazing when I look at the curriculums today that a computer science student would go through versus what it was, let's just say, a few years ago. And it's just amazing. They do twice the curriculum, and they just do it twice as fast. But the students just pick it right up because they were born with a computer in their hand, and it's just amazing how things move much faster now in the computer science world.
Thank you, Marty. Well said. For our last question this evening, Colt, will come back to you. Given Detroit's historic role in automotive manufacturing, how do you envision the Motor City's future evolving with the widespread transformation towards software-defined vehicles?
I can't emphasize enough what Marty said. I mean, the Detroit's success or failure in the future with vehicle technology is going to be around the engineers that we can produce. The people that want to even come here, or the people that we can home grow in our universities to just be technical and always stay on the cutting edge. I mean, that has always been the case. If you look at the most successful automotive companies in the world and the supply-based people that supply technology, it's always about who has that. It's even like a 0.5% advantage. The 0.5% advantage is from a money standpoint or from a future economic standpoint is not 0.5%. It's like 50%. You see the people that can just have that slight push to just be a slight advantage makes a huge difference in the people, the passion for technology is what's going to either make or break the future for us.
Paul, same question. With this conversation we're having around software-defined vehicles, what do you see for the future of the Motor City?
So, if you look, let's talk the barriers to entry to even be an automotive manufacturer, right? So basically with the advent of the electric drivetrains, it costs a lot more money, or a lot less money, I should say, to create your own brand, your own vehicle brand. China has quite a few handful of electric vehicles that they'd love to ship over here to the United States. So out in Silicon Valley, you have quite a few startups that were electric vehicle manufacturers. So, if you look at all vehicles, including that truck outside, they all have a few things in common, right? They got a way to drive, a propulsion system, they've got four wheels, they've got an interior, they've got a cockpit, and then they've got, some form of user experience. So, it's probably, for Detroit to really stay relevant, right, with all these competitors out there, you've got to create enough of a differentiator and a user experience for the passenger inside the vehicle that's going to separate, what you're trying to sell compared to all the other entrants that are coming into the market. So, a software-defined vehicle where you put those features in there and that you create that user experience that somebody loves the way maybe the center console works, things of that sort, the things that the customers have to interact with. That's going to probably be very important, and that's going to be done through differentiation through software. So,
Marty, what's your take on all this?
Well, I think that our competitive advantage, at least in the Midwest or in Michigan, it's not water, the nice weather we have today. I think it's the amount of engineers in the university system that we have all around us. Within 5 hours of Detroit, we are probably close to most of the top 25 engineering schools in the world. And if you just look what's in Michigan, what's in Illinois, what's in Indiana, even looking out over to what's in Toronto and Ontario, there's within 5 hours of here, we have enormous amount of engineers we're putting out every day. We can even look down south in Ohio too, even though I'm from Michigan. But there's just a huge amount of talent. We have Carnegie Mellon that's just 5 hours away. So, I think the Midwest has such a resource of people and talent and the infrastructure to keep this going. And you don't find that in other parts of the country. You go to Silicon Valley, they have a lot of engineers, but they're not generating as many new engineers as we are here in the Rust Belt in the Midwest. So I think we're really poised, especially now as the world becomes more distributed, to be much, much stronger here.
Marty, you mentioned that we are going to have a new crop of young students in software engineering, but what's the impact for existing jobs?
Well, on my projects, I have a lot more software engineers than I have hardware engineers today. The hardware is kind of cookie cutter. How many processors, how many cores. I'm going to run typically some sort of Linux-based operating system on it. But everything is done in software now. So I need a lot more software developers and a lot more QA engineers, because as the software gets more complex, there's just a lot more regression testing, and so it's just a shift. And we just same jobs, just shifting the roles.
A little bit. I definitely see from an Intrepid control system standpoint, if you rewind the clock 20 years ago, if you knew J1850 and CAN, just the hardware layer, you were an expert. And now we have control area network, FD, LIN, FlexRay, a lot more different hardware types of networks in addition to automotive Ethernet. And on top of automotive Ethernet is every type of communication you can imagine, protocol-wise, time synchronization, on and on and on. And the book that I wrote was 1,000 pages. It's not a little pamphlet. It's like this thick, and it's only on automotive Ethernet. So really moving forward, we see, especially from a network standpoint, for this SDV zonal architecture paradigm, it just means engineers got to stay sharp and learn a lot more than what we have in the past to be considered experts at the protocol and network layer, as well as software implementation layer, like Marty kept on saying, containers, the ability to have multi-software communication, inside of an ECU with many different containers, many different suppliers running in parallel means a lot of new technologies that are being brought in, and it's always been that way in the technology world if you go back in history. So it's kind of no different. It's just more and more of the same thing: innovation and who can be the fastest to market and the most knowledgeable.
Great software engineers, especially in the automotive space, they're hard to find. I mean, anybody, I'll put computer science in there too, but you can write really good code for automobiles, right? You'll definitely have a job long term.
We talk about the software-defined vehicle, and we talk about it as an integrated network and high compute clusters and so forth. What do you think the possibility of vehicle as a software development platform going into the next decade, where you have post-OEM, post-tier 1 developers developing apps and software to add to vehicle features, augment vehicle features? You had mentioned you want it to be your phone on wheels. Well, people write apps for phones that really give them their real power. Customization, someone had mentioned drive modes. What if there was a post-tier 1 company that developed drive modes or other features, upfitters and professional vehicle attachments, things like that. And Marty, just a quick comment. It would be nice if some of those computer science graduates knew what a resistor was and could find a 5-volt signal on a board. That would help a whole lot.
So when I go to conferences and there's OEMs involved, and even internal at OEMs about their future plans for electronics, because one nice thing about Intrepid Control Systems is that we're a global supplier to many different OEMs. We have good relationships with some of the key engineers at large OEMs around the world. So we have sort of a vision into what at least the thinking is inside of these OEMs, and it's absolutely 100% the case where a lot of OEMs want to have a cell phone on wheels where external companies come in, create software for their specific vehicles and generate revenue not only for themselves but also for the vehicle manufacturer, just like Apple, just like Google with Android. And we're already seeing this start to happen. For example, GM announced that announced that there's going to be a marketplace for GM vehicles where you can create, they're going to have certain APIs for certain features in the vehicle. We see it already happening now where software in the vehicle you can use your own cell phone, unlock a vehicle and drive away as rental. Near future, you're not going to be able to talk. You're not going to need to talk to anybody to rent a vehicle. You're just going to be able to just walk up with a cell phone. I'm going to pay $50 to go in this certain space, and that's what's happening. That's what's developing. Things like unlocking the doors, driving the vehicle, rentals, ride sharing. These are all things that are going to become more and more integrated with the OEMs as we move forward. And the OEMs recognize this. Whether it will be successful or not, we'll see. But they're definitely driving towards online marketplaces like the Google Play Store and Apple stores. This is what almost every major large OEM is driving towards. And the future looks exciting. We'll see if it's successful or not, but at some level we already see it happen, like I said, with the rideshare apps and so forth.
So, I can see, the type of software I deal with autonomy software, that's generally, there's a marketplace out there, but it's usually a supplier to an OEM relationship. It'll really probably never be anything because of the safety concerns involved in developing that type of software where you'd have an individual put a feature in that really affects the controllability of the vehicle. I could see features that could reside maybe in the center stack that control things that would be considered, non-operational, definitely non-critical to the operation of the car.
I think if we take this video of this panel and we watch it in 10 years, we'll laugh at ourselves because things are going to evolve very quickly. Either people are going to say you actually have to pay for something or it just didn't automatically happen. So I think the software is accelerating. The personal assistants, the AI assistants, all that is really accelerating. And, of course, all of these vehicles are going to have an open platform to install additional plugins, because if I want to buy this car, my software vision of this car is going to be open and extendable. And, maybe I like Google Maps, or maybe this person wants Waze. I mean, it already happens today. And people buy cars based on the apps they can run on their cars today. And it's only going to get worse. I don't know if worse or better, but there's just going to be so many things that are going to be automated. So 10 years from now, if we go back and we watch this, I think we'll all kind of laugh at where we are today and how simple things are in the future.
Colt, Correa, Paul Fleck, Marty, Gubow. Let's give them a round of applause. Thank you, everybody, for being here. Thank you to Intrepid Control Systems for hosting SDV Social 2024. Enjoy the rest of your night. Thank you.
Thank you.